So this would be 7k to the 2/3. There's the denominator. This would be 10x to the 1/2, 6x to the 3/2, 5r to the 5/3. This would be 4x to the 4/3. This would be 6r. Oh, weird coincidence. Also to the 4/3. These would be, this is 6k thirds, whole thing to the 4th power. This would be 7x square rooted the entire thing to the 3rd power. This is the square root of x. This is 5k. Some people feel the need to put a 2 in there, but remember, just like in number 9, it's a square root. We don't need the 2. You should assume it's a square root unless they tell you otherwise. P to the 6th root and the whole thing to the 7th power. 5m, I don't need parentheses there. 5m square rooted to the 5th power. Okay, the next page, we're simplifying. 128, I know, is 2 to the, what is that? 7th power. So this is 2 to the 7th power and 4th rooted, which means I could write it like that, which is 2 to the 1 3/4, which means this is 2 times the 4th root of 2 to the 3rd power. 256 is 2 to the 8th power and 3rd rooted. So that means this is 2 to the 2 2/3. So this is 2 squared times the 3rd root of 2 squared. That goes there. That goes there. And the 2 squared goes outside. So we can just call this 4 times 3rd root of 2 being squared. 48 is, that's 16 times 3, so that is 2 to the 4th times 3. But we're taking the 4th root of all of that. So this is 2 to the 4th rooted, times 3, 4th rooted. So that's just 2 to the 1, which is 2, times the 4th root of 3. 250 would be, 250 is 25 times 10. That's 2 squared times another 2 times 5. So this is 2 to the 3rd times 5, all 3rd rooted. So that would be 2 to the 3rd rooted times 5 third rooted. So that's just 2 to the first times the cube root of 5. And these last few. Here we go. I want to write. There we go. 96. We handle the same way as the numbers in the last ones. The variable parts are actually the easiest parts here. Like I know this is going to end up x to the 5/4 and y to the 8/4. And then I'm going to simplify that with roots. 96 is 2 times 48. So 2 times 48, which means it's 2 times 3 times 16. 16 is 2 to the 4th. There's another 2. It's 2 to the 5th, 4th rooted, and 3 4th rooted. All right, so I'm pulling out of there. 2 to the 4/4 is really 2 to the 1st. And 2 to the 1/4 is going to stay underneath. That didn't get written the way I wanted. It's going to stay underneath that 4th root symbol. That goes there, and the 1/4 left over is what goes inside. We have 3 to the 1/4, that's going to stay underneath. X to the 5/4 is x to the 4/4, which is x to the 1, that stays outside, and the 1/4 remaining stays inside the radical. And y to the 8/4 is really y to the 2nd power, so I'm going to have the y to the 2nd power outside. All right, so here's my final answer. I'm going to make some space. Nothing's erasing. Why? There we go. Okay, so I'm going to have 2xy squared times the 4th root of, the 2 times 3 is 6x, and that is my answer for number 17. For number 18, we do the same thing, and 112 is 56 times 2. 56 is 8 times 7, so I have 8 times 7 times another 2, and this is 2 to the 3rd, and another 2 is 2 to the 4th, so I have 2 to the 4th times 7 times m to the 7th n squared, but all of that is being 4th rooted. So here's the thing, 2 to the 4th, 4th rooted is just 2. M to the 7th, 4th rooted would be m, but there's 3 powers of m that stay in the radical. Because that's like a leftover, it's like the remainder when you divide 7 by 4. 4 divided by 4 gives me no remainder, gives me a 1. This 7 has to stay inside. Oops, I got 4 now. M to the 7th. I get 1 full power of m out there because 7 divided by 4 goes in once with some left over. What's left over is 3 powers of m. And then n squared stays inside there. So there's your answer. Put the dot. I'm just going to write down the answers for these last two. so I can get through them a little more quickly. 128 we've already done. As far as factoring it, it's 2 to the 2 to the 7th. So this is 2 to the 7th, m to the 8th, n to the 5th, and it's all cube rooted. So that means 3 goes into 7 twice with 1 left over. So that's 2 to the 2nd. And the 1 left over goes inside. M to the 8th, 3 goes into 8 twice with 2 left over. So that's m to the 2nd. And there's 2 left over inside. M to the 5th, 3 goes into 5 once with 2 left over. So that's an n, and 2 left over means n squared goes in there. Oops, I again forgot to put the 3. Let me rewrite this a little bit more neatly. 2 to the 2nd is 4. M to the 2nd, n. And then that's all being multiplied by the, not 4th root, but 3rd root of 2m squared n squared. And number 20. 32 I know is 2 to the 5th. And then I have x to the 5th. And then I have y to the 6th. But that's all being 3rd rooted. So each one of those exponents really should have a 3 in its denominator. But then simplify 5/3 and 6/3 and so forth. So that fraction is really a division. So what we end up with is 5 divided by 3. The new exponent is 1, and you have 2 left over. So underneath the radical, you're going to have 2 squared. There's your leftover 2. Same thing with the x. You can call out an x. You don't need these exponents of 1. I'm just putting them in there to be clear. Exponent of 1, and you have 2 powers of x left over. And y to the 6th, 6 divided by 3 is 2, so you get y squared and nothing left over that stays inside. So there you go.